Exam in 2018. So it is to match the type of column question. So we have to match the column here. So it is asking the symbols for the respective diode. So the symbol for the Zener diode is this. So this will be representing the Zener diode. So this is the representation for the Zener diode. What will be the symbol for the PN junction diode? This is the symbol for the PN junction diode. And what is the symbol for the tunnel diode? Tunnel diode symbol is this. It's the symbol like T. It's having symbol like T, right? Like this. So this is the symbol for the tunnel diode. And what is the symbol for the Schottky diode that we have just seen is this. So this S is representing the Schottky diode. You can remember it like this also. So this is the Schottky diode symbol. So this is the very basic question that was asked in UGC NET exam. So they can also ask you different types of symbols for the respective diodes. Let's see some other questions. So the Schottky diode consists of semiconductor junction. What kind of junction it has? It always has metal semiconductor junction. So the option that would be right is C. It always have metal semiconductor junction, and generally it has metal and type semiconductor junction. The next question is Schottky diode is used on high frequency, that is more than 300 MHz, as a rectifier. Is this statement true or false? So yes, it can be used as a high frequency rectifier because of low storage time that we have seen. So that will be true. So the statement given here is true. What is Schottky diode is also known as? This Schottky diode is also known as Schottky barrier diode, and it is also known as hot carrier diode. It is also known as hot carrier diode. Hot carrier means it is because of majority only. The charge carriers are majority carriers only. So Schottky diode is a majority carrier device because there is no holes present. Majority carriers, and those majority carriers are electrons only. So the whatever current is flowing is due to majority carrier, that is electron only. So it is also known as unipolar device. It is a unipolar device because it has only one polarity of charge carrier, that is electron, that is negative, right? So it is unipolar device. Whereas in case of PN junction diode, we have seen the PN junction is a bipolar device because it has two charge carriers, that is electrons and holes. Okay, so this statement is again very important regarding Schottky diode. So we can say option D would be the correct answer. Answer A and B. This is the end region. Now what will happen? Suppose it is in the forward bias condition. It is in the forward bias condition and holes will be moving from P to N and electrons will be moving from N to P. Now, if a forward bias PN junction is suddenly reverse biased, then what will happen? This electron that is present here in the P region now it has to come back to the N side, right? It has to return back to the N side and it will need some amount of time to come back. And we generally know the PN junction is going to conduct in forward biased, and in case of reverse bias, it should be considered as open circuit. That means current should be approximately 0. So as soon as I make the diode reverse bias, it should stop the conduction, but it will not happen. What will it do? The carriers will be still flowing and it will need some amount of time to current to reduce to 0. So the amount of time that is required is known as reverse recovery time. So that can be represented by some graph. Suppose I am plotting a graph between voltage and current. See, this is the voltage. So initially the voltage was forward biased and then suddenly it is reverse biased like this. So we had the current that was flowing. Initially the current was flowing like this, and as soon as the voltage is reversed, the current will not be reduced to zero, but it will be flowing. It will be flowing, and it will be flowing in the opposite direction. So equal and opposite current will be flowing in the opposite direction initially. Then it will start decreasing. After some time, when electron has come back to the position, now current will start decreasing. So that can be made like this. Okay. This is the amount of time that is required to current to become 0. So we can say this is time t1, this is time t2, and this is time t3. Then at time t1, the voltage is reversed suddenly. The current will be flowing. Suppose this is the I1 current. Now the current will be flowing in the opposite direction with the same magnitude. And this is known as storage time. The amount of time that is required by the electron to come back to the initial position is known as the storage time. Now the current will start decreasing, so that is known as the transition time. This time is known as TR. So reverse recovery time is equal to TS plus TR, and the value of TS plus TR should be low, or we can say reverse recovery time should be low to operate the PN junction diode as a switching circuit. So in switching circuit we should have very low reverse recovery time. So as soon as I forward bias, it should start conduction. It should start behaving like a short circuit, and as soon as I reverse bias it, it should start behaving like a open circuit. So which is practically not possible. It will take some time for a PN junction diode to stop the conduction, and this is known as the reverse recovery time. But that reverse recovery time is very low in case of Schottky diode. So this is very low in case of Schottky diode, and it is in the range of picosecond. That is in the range of picosecond, that is 10 to the power minus 12 seconds. That is quite low value. So that is another advantage of the Schottky diode. So that's why it was being used as in the switching circuit or in the rectifier circuits